Hello, Gritan. How are you today? So I hope you're doing fine. In this video, I'm gonna continue the explanation about dynamic electricity, okay? To be more specific, I'm talking about potential difference in an electrical current. If you didn't watch the previous video about current intensity, please watch that first or you're gonna be lost in this video, okay? So go back there, watch that first, then come back in this one after. Okay, so we're going to talk about potential difference in an electrical current. What's this? What's potential difference? In any electric device, we have the electric potential. What's this? Is the energy that can be supplied by each of the charges in an electrical current, which is transferred from one point to another. So every time I have an electric current, I have charges being transferred, right? This charge also transfer energy. The amount of energy that this charge supply for an electric device, we call electric potential. So let's understand a little bit better. In an electric circuit, this energy of the charge comes from the power supply. So it depends on the power supply that you are talking about. Power supply is any device capable of creating electrical energy, generating electrical energy. What kind of supply? For example, a battery. A battery, they supply energy, and this energy is transformed from chemical energy to electricity. So battery is one kind of device that we call power supply that supplies the energy. Which energy? Chemical energy. And this chemical energy is transformed in electricity. For example, in this case, to turn on the lamp. Another kind of power supply is a generator. What a generator does? It transforms mechanical energy into electricity. And how? So then it's going to depend. For example, if it's a generator from hydraulic power, it's going to be the movement of water. That is, this mechanical energy is being transformed in the generator, okay? So if you didn't watch the previous video, please watch that we talk better about this. Okay, so what's electric potential? It's how much energy is being supplied by the charge from, for example, from the battery or from this generator that is being transferred to another device, for example, in a lamp, okay? How do we measure it? To measure this amount of energy, we call potential difference. Why is that? Is the amount of energy that is being transferred between 2 points in electric circuit. So let's see an animation here. For example, here I have 2 charges, okay? In one side, for example, it's all negative, so and the other one is neutral. When they are transferred from the other one from the other, the lamp in between turn it on. Why? Because there is a difference in the charge between these 2 charges from the left and from the right. When these charges are equal, so it stops moving, the lamp will not turn on anymore. Why? Because I just create energy, electricity, when there is this movement. How do I do this movement? By the difference of charge between the 2 of them. And how much I transfer. This how much we call potential difference. How much has been transferred, okay? So if I don't have this transfer, I don't have potential difference, so I don't have charge or electricity or energy being transferred, okay? This potential difference is measured in volts or V, and it can measured in an instrument called voltmeter. So this is the voltmeter. The voltmeter measures the potential difference between 2 points, okay? So I always need to have 2 points because it's the difference between the charge of these 2 points. And this voltmeter calculates the amount of energy each of the charge transfers to a circuit element, okay? So if I have a battery, this battery is supplying the charge together with the energy. And then this charge, this energy is transferred to a circuit element or a device, a lamp, anything that we are talking about, okay? Okay, now let's go do some calculation. This potential difference is symbolized by the letter V because of the volts, okay? And measured in volts. 1 volt, 1 V, is the same as 1 joule per 1 coulomb. So I can write this formula here. 1 volt is equals to 1 joule that we measure energy and 1 coulomb that we measure charge. So if I have just 1 volt, what does that mean? It means that the energy of 1 joule, so 1 joule of energy, has been supplied per each coulomb of charge that has been transferred. Okay, so if I transfer 1 coulomb of charge, I'm supplying this device of 1 joule of energy. This means 1 volt. So for each 1 volt means 1 joule of energy is being supplied by each charge, each coulomb of charge that I'm transferring, okay? So for volt, we also continue using V, okay, for potential difference. Joule is a measure of energy, okay? And coulomb is charge. How do I represent charge? By letter Q. So V is the potential difference measured in volt. E is the energy that we measure in joule. And Q is the charge that we measure in coulomb, okay? So it's really simple, but the most important here is for you to understand what's going on. So why do I say that's potential difference? Because it's the difference of the charge of 2 points. And when the charge is transferred from one point to another, I supply that device with energy. Then this energy is going to turn on the supply, the device. Okay, so let's do some problems just to understand better this concept, okay? Example 1. Remember, we always read one time. The second time we read, we highlight. And then we're going to make a list, okay? So first, I'm going to just read. What's the energy transferred by the movement of 4 coulombs of charge through a potential difference of 6 volt? Okay, so I just read. Now I'm going to highlight the information. What's the energy transferred by the movement 4 coulomb? So I have here 4 coulomb of charge through a potential difference of 6 volt. Okay, and let's remember the steps. Let's follow the same steps. Step 1, make a list according to the formula. Now we are using the formula of volt because I want to calculate the energy transferred. So volt is equal to the energy divided by the charge. V, I have potential difference of 6 volt. Energy, do I have? No. So I need to calculate. And charge, how much charge I have? 4 coulomb. So I have 4 coulomb. Step 2, check the units. So for the units, my potential difference should be in volt, yes. And my charge should be in coulomb, yes. Then my energy will be in joule. Okay? Now, step 2, done. So I don't need to make any change. Step 3, replace in the formula. So I'm going to write down the formula again and I'm going to replace. So V is 6, E I don't know, and Q is 4. So V 6, energy I don't know yet, and charge 4 coulomb. Step 4, simplify and calculate. So I'm going to simplify. How do I do this? I can do cross multiplication. So E times 1 equals 6V times 4. So E is going to be 6 volt times 4C, or in this case, I'm just replacing to explain to you that volts is the same as joule per coulomb, okay? It's the same. 6 times 4, 24. Why do I have just joule? Because this coulomb here is cancelled with this one. So I just have joule. So my energy is 24 joule. And now my final answer. The energy transferred is 24 joule. Okay? So let's do the next one. Example 2. How much electrical potential is generated during a process where 4 times 10 to the power of minus 8 joules of work are done in the movement of a charge of 2 times 10 to the power of minus 6 coulomb? Okay, now what do? I read again and I highlight. How much electrical potential, so it's asking me the electrical potential, is generated during a process where 4 times 10 to the power of minus 8 joules of work or energy are done in the movement of a charge of 2 times 10 to the power of minus 6 coulomb. Now, list. Let's write down the formula again that I need to use. V. Do I have the V? No, that's what I'm asking, the electrical potential. Do I have E? Energy? Yes, so energy is 4 times 10 to the power of minus 8 joules. And do I have the charge? Yes, so charge is 2 times 10 to the power of minus 6 coulomb. Step 2, check the units. Energy in joule and charge in coulomb. Do I need to change anything? No. Replacing the formula. V, I don't know. E, I know. 4 times 10 to the power of minus 8. And charge is 2 times 10 to the power of minus 6. So I just replace. Step 4, I need to simplify. So how do I simplify here? First, the easiest way, I'm going to divide these two numbers. 4 divided by 2. And then I'm going to divide these two together. It's the easiest way to do this, okay? 4 divided by 2, 2. 10 to the power of minus 8 divided with 10 to the power of minus 6 is the same as 10 to the power of minus 2, okay? So, joules per coulomb. And this joules per coulomb is what? How can I replace joule per coulomb? By volt. So it's going to be 2 times 10 to the power of minus 2 is the same as 0.02 volt. So elaborate the answer. How much electrical potential is generated? So the electrical potential generated is 2.02 volts. Okay? Next one. A potential difference of 10 volts exists between 2 points, A and B, within an electrical field. What's the magnitude of charge that requires 2 times 10 to the power of minus 2 joule of work to move it from A to B? Now let's read again and highlight the information that it's given. A potential difference of 10 volts exists between 2 points, A and B, within an electrical field. What's the magnitude of charge? So it's asking about the charge that requires 2 times 10 to the power of minus 2 joule of work to move from A to B. Okay, first step, make a list. So according to the formula, what do I have? Do I have volt? Do I have potential difference? Yes, of 10 volt. Do I have energy? Yes. 2 times 10 to the power of minus 2 joule. Do I have charge? No. That's what I'm looking for. Step 2, check the units. So potential difference in volts, fine. Electrical energy, energy in joule, it's fine. So I don't need to change. Replacing the formula. So here's the formula again. So volt, 10 volts. So potential difference 10 volts. Energy, 2 times 10 to the power of minus 2 joule. And I don't know my charge. Now simplify and calculate. How can I simplify this one? The first step is to do cross multiplication. Let's just erase this. The first step is cross multiplication. I'm gonna put a 1 here and cross multiplication. This one times this one, this one times this one. I'm gonna multiply the charge first because I want to make this easier to calculate. So 10Q is equals to 2 times 10 to the power of minus 2. What do I do now? I need to, this 10 goes over there, dividing. So Q is equal to, I'm just simplifying here, 2 times 10 to the power of minus 2 as 0.02, divided by 10. Now, what happens here? My volts is the same as joule per coulomb. If I have joule here and joule here, they cancel each other. So I just have coulomb. So my charge will be 0.002 coulomb. What's the question again? What's the magnitude of charge? So the magnitude of the charge is 0.002 coulomb. Okay? One more. It takes 15 joules of work to bring 3 coulombs of positive charge from infinite to a point. What's the electrical potential at this point in an electrical field? Read again, highlight now. It takes 15 joules of work to bring 3 coulombs of positive charge from infinite to a point. What's the electrical potential at this point in an electric field? So electric potential or potential difference is the same, okay? Let's make a list according to the formula. Do I have V? Do I have potential difference? No, I need to calculate. Do I have energy? Yes, 15 joules. Do I have charge? Yes, 3 coulomb. Check the units. Energy in joule, charge in coulomb. It's fine? Yes. Step 3, replacing the formula. So V, I don't know. Energy, 15 joule. And charge, 3 coulomb. Now simplifying. I just need to divide. It's very simple. 15 divided by 3. 5 joules per coulomb. And joules per coulomb I can replace by volt. So my electric potential is 5 volt. So what's the electrical potential? The electrical potential generated is 5 volt. Okay? Okay, so take a breath, and let's go to the last one. The electrical circuits in our homes usually supply a potential difference of 120 volt. What's the amount of energy provided by a charge of 200 coulomb? So let's read again and highlight. The electric circuits in our home supply a potential difference of 120 volt. What's the amount of energy provided by a charge of 200 coulomb? Okay, first step, list. Do I have V? Yes, 120 V. Do I have energy? No, that's what it's requiring me. Do I have charge? Yes, 200 coulomb. Step 2, to check the units. Potential difference in volt, charge in coulomb. Step 3, replacing the formula. So V, 120. E, I don't know. Coulomb, 200 coulomb. And step 4, simplify and calculate. The first thing you need to do is to do cross multiplication. So I'm going to multiply E by 1 to make this easier, and 120 times 200. So E is equal to 120 times 200. V is the same as joule per coulomb. Remember that. So when I'm doing calculation, I can cancel the coulomb here and the coulomb here. So I just have joule. So my energy will be 120 times 200, 24,000 joule. So what's the question again? What's the amount of energy? So the energy transfer, or the amount of energy provided is 24,000 joule of energy. Okay? So that's it for today. Thank you so much, and please solve the exercise in the form, okay? Thanks so much and have a nice day.